1 battery, 3 months, 0 fixes, break time equals 0. 6 is / in January 2013, a single lithium fire in the belly of a 787 grounded every Dreamliner in service. It was the first FAA grounding of a U.S. airliner type in 34 years. Here's why that stung. The 787 was Boeing's flagship, a $200 million plus carbon fiber jet betting on electricity instead of heavy hydraulics and pneumatics. Roughly 50 Dreamliners sat parked across a NA, JAL United and others. Every grounded day meant lost revenue for airlines and a bruise on a brand new plane. So what actually forced the freeze? It started with 2 fires in 9 days. On January 7, 2013, a Japan Airlines 787 sat empty at Boston Logan when its battery caught fire. It smoldered and vented fumes for hours after everyone was off the plane. Firefighters couldn't just put it out. Then 9 days later, an all-Nippon Airways flight was climbing over Japan when the crew got a battery warning and smelled smoke in the cabin. They made an emergency landing at Takamatsu and evacuated down the slides. 2 of the newest jets in the sky, both undone by the same small box. That's when regulators stopped waiting. On January 16, 2013, the FAA issued an emergency airworthiness directive, an order that grounds a plane on the spot, freezing the entire U.S. 787 fleet. Within days, aviation authorities around the world followed. No airline flew a Dreamliner. Think about how rare that is. Planes get single model warnings all the time. A full worldwide grounding is a nuclear option. The last time the FAA grounded an American airliner type was the DC-10, back in 1979. So what was inside that box that scared everyone this badly? Now the why. To understand the fire, you have to understand why the 787 carried these batteries at all. Older jets run a lot of their systems on hydraulics, and compressed air bled off the engines. Boeing went a different way. The 787 was the more electric plane. It swapped heavy pipes and pumps for electrical systems, which meant it needed a lot more stored power on board. Here's the trade-off. To store that power without hauling extra weight, Boeing picked lithium batteries. The kind of lithium chemistry it used, lithium cobalt oxide, packs far more energy into each kilogram than the older nickel-cadmium batteries most jets relied on. 2 of these lithium packs, built by the Japanese firm GS Yuasa, handled starting the small-tail engine and backing up key systems. Lighter batteries, less fuel burned, more range. On paper, a smart trade. But energy density cuts both ways. The very thing that makes lithium cobalt so good at storing power makes it dangerous. Cram that much energy into a small cell, and if that cell overheats, overcharges, or gets physically damaged, it doesn't just fail quietly. It has a lot of stored energy looking for a way out. Which raises the real question, what happens inside one cell when it goes wrong? Here's the chemistry that did it. It's called thermal runaway, and it's a chain reaction that feeds itself. Picture 8 battery cells packed side by side. One cell overheats from a short, a defect, overcharging doesn't matter. That hot cell dumps heat into the cell next to it. Now that neighbor overheats and releases its own heat, which cooks the next one. Each failure makes the next one worse faster. That's the runaway part. It accelerates. And it gets uglier. As a lithium cobalt cell breaks down, its cathode, the metal oxide core, starts releasing oxygen. A fire needs oxygen. So this fire brings its own. You can smother a normal fire by cutting off air. This one doesn't care because the fuel and the air are baked into the same little brick. It burns past 500 degrees Celsius, hot enough to melt the metal inside. In the 787's 8-cell pack, one failing cell was enough to cascade through the whole battery, venting flammable liquid and molten metal. That is not a guess. It's exactly what investigators found when they cut open the charred Boston unit. One battery that had cooked itself from the inside out. So if you know how it fails, you fix it right. That's where this story turns strange. This is where it gets strange. Break time equals 0, 6 is / 2 teams tore the batteries apart. America's NTSB and Japan's JTSB, the agencies that investigate transport disasters. And after months, they never pinned down a single definitive cause. There was no obvious manufacturing defect that explained everything. No smoking gun. Sit with how awkward that is. You can't fix a problem you can't fully name. If you don't know exactly which flaw lit the fire, you can't promise you've removed it. So Boeing made a hard call. Stop trying to guarantee no cell would ever fail. Assume any cell might. Then engineer the plane to survive it anyway. Instead of preventing thermal runaway, they built around it. The redesign had 3 parts. First, a sealed stainless steel box strong enough to hold a raging battery fire inside. Second, ceramic insulation slotted between the cells to slow that domino cascade from spreading. Third, and this is the clever bit, a titanium vent tube that pipes the smoke, heat, and gases straight out through the skin of the plane overboard before they can build up. Contain it, insulate it, vent it. They didn't cure the disease. They quarantined it. But would a regulator actually sign off on saying they can't stop it, they just cage it? And here's the resolution. They did sign off. After roughly 3 months on the ground, the FAA approved Boeing's redesigned battery enclosure in April 2013, and the Dreamliners flew again. Look closely at what actually got fixed, because it's the whole point of this story. Boeing never fixed the chemistry. The cells inside are still lithium cobalt. They still can overheat. They still can run away and burn past 500 degrees Celsius. Boeing simply accepted that and put the fire in a cage it can't escape. The steel box holds the heat. The ceramic slows the spread. The titanium tube dumps the smoke overboard. Yes, the redesign added weight and cost, and the batteries were never cheap. But it let the fleet return. And here's the payoff of that choice. A repeat cell failure stopped being a crisis. When a cell has since misbehaved, the box did its job. A contained event, not a grounded fleet, not a headline. The 3-month freeze was solved not by making the battery safe, but by making its failure survivable. So the lasting lesson isn't really about batteries. Sometimes engineering can't erase a failure, so you engineer to survive it. The 787 flies today on that same lithium chemistry, just inside a box built to lose gracefully. Next time, how one loose sensor probe can convince an autopilot the plane is falling when it isn't.